And now we have Loris Maestri, sorry. Loris Maestri from Radici Group. Radici Group is a big company in Lombardy, producing for all over the world, producing polyamide fibers and also other synthetic fibers. Yeah. And he has the problem to recycle.
Okay, thank you. To be quick, yes. Okay, so you already introduced very quickly Radici Group. I also put some slides, but just to let you understand why I'm showing you today 2 case studies. In our company, we are vertically integrated in polyamide business, meaning that we can start from chemical compounds and obtaining polyamide 6, 6,6, or other kind of polyamides. And then we can use them in different fields, both in fiber area, in which I belong, and in plastic. My colleagues are not here, so I can call them plastic or high-performance polymer for other application. The group, okay, it's quite big in terms of the number, turnovers, and people working on it. And we are located more or less all over the world, but the fiber business and the recycling business is actually located in Italy and in Europe. Here you can see the structure, as I said before, so starting from the specialty chemicals in which we are obtaining the chemical intermediates for polymerization, the high-performance polymers in which we create compounds and polyamide polymer chips to be used in many applications, and the advanced textile solution in which we use this kind of polymer to spin yarn and fiber. We also have a polyester business line. We are not producing polyester, actually. We buy the chips from the market and we spin them into a yarn. Okay, I move to the most interesting part of the presentation. As you can imagine, we are constantly working and researching for new solutions in terms of sustainability. And here I've summed up our main strategy, let me say. First of all, we start from low impact production. So we are constantly improving our production in order to be less impacting as possible. And then we have 3 different pathways to achieve our sustainable strategy. One of them is using recycled material, using the solution dye technique. So providing yarn which are already colored, so without using water or other chemicals, and bio-based, bio-origin material that we can both polymerize or obtain from the market. The advantage of using, in our case, polyamides and polyester is that those kind of material are thermoplastic, so that they can be recyclable in a thermomechanical way. Recycling of polyamide in Radici Group was done since many years. You know, Bergamo people are very pragmatic, very concrete people. So 50 years ago, they were already collecting production scraps, trying to convert them into a new product in an optic of optimizing their production, very well before then sustainability was a trend topic. Today, of course, we have all the know-how and the experience on this topic, and we can think to an open loop use of our material. So starting from the polymerization, which is in our company, we can collect all of the production scraps. We sort them, and this is a very tricky point, very crucial in the process. And depending on the quality of the material that we are able to collect, we can go back in the spinning line, which is the most critical application that we have. Otherwise, we can move this material to the compounding area, which is less critical. If we go in the compounding area, we can go in many applications. I put some automotive application. While if we have the quality which is suitable for spinning, we can go back in the textile business. Of course, If we are considering only production scraps today, we are integrated in this process. We can use our own production scraps and obtain a new product, which is Recycle. Our brand name is Recycle. If we move to a post-consumer case, the problem starts to be a little bit bigger. We know today that garments can have different pathways when they reach the end of their life. So first of all, we can reuse or repair the garment. We can go in the mechanical recycling pathway or otherwise in chemical recycling. If we move from to left to the right, we are moving back to chemical building blocks. So if we go in the chemical recycling, of course, we can go back to the very starting point of the process, but we need much more energy, we need chemicals, we need some aspect that we have to keep in our mind. So today we are focusing on mechanical recycling and obtaining the polymer back again. I would like to show you two case studies that were successfully, let me say. They started from pilot projects. One of them is the recyclable skiing suit. Radici family, which is owning Radici Group, also has a skiing club. And each year they are asking for a new design for their athletes. And they said, okay, why not producing or trying to produce a skiing suit according to the eco-design guidelines. And that's exactly what we did for this project. So we analyzed a typical skiing suit. We found out that in a skiing suit there are more than 50 different materials inside. We try to convert them into a polyamide or compatible polyamide based material. And then we ended up with a final product, which is a professional product. Actually, the skiing club is using this skiing suit. And it was designed to be recyclable. So all of the parts which are not polyamide based are easily detachable from the skiing suit. And also the percentage of material which are polluting, let me say, the skiing suit are in a certain percentage that we can manage in our recycling plant. Here you see what we have done with very easy images to understand. On the top of the slides, you can see polyamide 6 garments with a certain amount of pollutant. In this case is elastane, which is a typical composition of fabric, so polyamide and elastane with a standard recycling process. You can see that elastane migrates from on the surface of the sampling, and the aspect of the polymer inside, the polymer matrix inside is, as you can see in the SEM image on the right here. Of course, mechanical properties in this case are very poor, and this material cannot be reused in other application. Thanks to the research and the know-how that we have, we were able to move from the top of the slide to the bottom one. You see the surface is much more smooth and uniform. And also at the SEM analysis, you have only small dots, which are elastane present in polyamide. In this case, it's polyamide 6. So the project was demonstrating the circularity of a garment in an open loop, let me say, approach. So starting from a recycled fiber, we can make a skiing suit. The skiing suit is used, and after, when it reached the end of life, can be mechanically recycled and turned back into a new polymer for other application. As an example, a skiing boot if we want to stay in the same application. The second case study regards polyester. As we heard before, we all know that recycled polyester today is mainly coming from bottles. Of course, if we think in a sustainable and also in a logical application of polyester, we should move from bottle to textile to textile recycling approach. And this is exactly what we are working on. And since 2022, we are trying to work together with a machine producer and also fabric producer to collect material and try to recycle them back. Polyester instead of polyamide has a drawback, let me say, is that while we are recycling, thermomechanically recycling polyester, mechanical properties are dramatically dropping during the process. So we have to investigate how to solve this problem. During those years, we did exactly this work, and we ended up with another project that we showed the first time in ITMA last year. And here you see we collected some sports jersey t-shirt made out of 100% printed polyester. We recycled them back, we spun back the polymer, and we were able to obtain a new t-shirt. I also have a very short video that it's explaining exactly what I said now.
If you want to achieve what has never been done before, you need ambition. This is what brings you from what if to let's do it. So, the question is, can you fully recover polyester textile waste, such as from a bike jersey? To make this fiber-to-fiber process feasible, the R&D teams of 3 companies joined forces. Sportstex, who specialize in the production of sportswear, Radici Group, with their many years of experience in circular economy, and Pure Loop, a company specializing in man-made fiber recycling machines. Shimano was the first company to embrace this sustainability project when it branded the first jersey coming from this supply chain collaboration. The first step in this chain is the sorting of used garments at Erdotex. Thanks to their process-specific procedures, Erdotex makes it possible to recycle fibers, with the aiming of developing a real industrial process. What follows is shredding and extruding with machinery from Pure Loop, a company within the Irima Group. Before pelletizing, the IV level of the feed material is increased to the same level as virgin material. The next step is to produce yarn from the recycled pellets at Radici Group, where the R&D people are able to optimize the spinning process to obtain high-quality fibers that satisfy both technical and environmental specifications. The yarn is then knitted into fabric. The garment itself is then made and customized by Sportstex, which is part of the Tex Market Group. Once scaled up, this sustainable circular economy technology will make it possible to easily produce recycled polyester garments that, at the end of their life, can be recovered again. Thanks to this project, the partner companies proved the feasibility of circular economy with recycling projects that commoditize materials otherwise considered as waste, reducing the environmental impact of the textile sector.
Okay. In both cases, I would like to highlight that both in the polyamide example, so the skiing suit and also this t-shirt, is fundamental to involve all the supply chain and work together to design the product and to already think of the end of the life of this product. Very last topic, it's just one slide. We heard about data before. I hope there are not zombies in those one, but actually, just to say that why is important to choose the right material and trying to move to a circular economy. Here I have reported some numbers, some comparison actually, comparing polyamide impact as a global warming potential. So if we compare the polyamide 6 production in the world as a reference, we can see the difference if we choose polyamide 6 manufactured in Europe, or in our case here, the green one made in Radici Group. What is important to understand is that, as you can see here, the recycled one has less than 50% of impact with respect to the virgin material. Of course, we cannot move all of the polyamide consumption to recycled one because it's not feasible actually. But going in a circular economy, for sure, we can move in this direction. So those data were evaluated internally using primary data, so they are actually punctual and representative of the business. Okay, I'm done. Okay, so thank you. Very quick. No,
Thank you to Radici Group. Another thing I didn't hear, but polyamide can be done also with bio-based raw material from not from castor, from a castor oil. Yes, okay. And you have also 60% and 100% of